The new thing that's introduced in question 2 is part I, determine the non-permissible values of theta. We're actually going to do that at the end after we prove the identity, because it's easier to see once the identity is proved. Non-permissible values, well, with trig identities, you have to check where you're dividing, because you're not allowed to divide by 0. So once you've done your proof, you're going to look through your entire proof and say, where are all the places I divided? And where could that possibly be equal to 0? So we're going to start with the proof in A. We have cotangent theta over cosecant theta equals cos of theta. Draw your line to split it up. I take a quick peek to see, can I get both trig sides the same trig function? I don't see any shortcut. If I don't see any shortcut, start by changing everything to sine and cos. Cotangent is cos theta over sine theta. Again, my main line I'm going to make a little bit thicker. Cosecant is 1 over sine theta. The right-hand side is already a single fraction. It's cos theta over 1. So now on the left side, I'm dividing by a fraction. I'm going to multiply by a reciprocal. And I notice that these factors are the same, so they simplify. And we just get cos theta. And we're done our proof. Okay? Now that we've finished our proof, I'm going to take out my highlighter and check where I'm dividing. I'm dividing by sign there. I'm dividing by sign there. I'm dividing by sign there. The only thing that I'm dividing by, besides cosecant right here, is by sine. And the only way to figure out cosecant would be to change it to sine, so you don't have to worry about the cosecant. The only place that we're dividing by 0 is dividing by sine. So our non-permissible value, we know that sine of theta can't equal 0. When is sine equal to 0? At k pi, so theta can't equal k pi, where k is an integer. Yes? If you tried to solve cosecant equals 0, you'd have to change it to 1 over sine anyways. And in this situation, when I multiply both sides by sine theta in this equation, I get 1 equals 0. In fact, cosecant is never equal to 0.
Do you have to write the theta thing too? Like the theta is not equal to k pi?
Yes, you have to, because it says in the question,
What is k?
k is any integer. So k could be 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, 5, and so on. Because if you drew your sine graph goes through an x-intercept at 0, then pi, then 2 pi. If you kept going, then 3 pi, then 4 pi. So our zeros of sine are k pi, and wherever sine is equal to 0, you'd be dividing by 0. If we look at the second one, where's the first one? Again, and do our proof, change secant to 1 over cos theta, and then get a single fraction on the bottom, which will give me, this is my main divide line. Sometimes this happens, and people struggle because they're like, I've got a fraction on the bottom, and they say, I don't have a fraction on the top. But you do have a fraction on the top, because you could write that all over 1. So now I can multiply by the reciprocal. On the top, I have 1 plus cos theta. I can write over 1 if I'd like. On the bottom, when I multiply by the reciprocal, This one's going to get grouped together. This one's going to get grouped together because of that plus sign. Do we have any factors that are identical? Yes. Oh, look at that. It's already done for me. My 1 plus cos thetas would cancel out, and I just get cos of theta. And we're done. So now take out my highlighter. Maybe take out my highlighter. Where am I dividing by 0? Or sorry, where am I dividing? Different things I'm dividing by. And so, cos theta can't equal 0. Theta can't equal. You remember the two ways to write these zeros of cos theta? There was the odd numbers times pi over 2 where k is an integer. Or you could have written it as, well, I know that pi over 2 is one of my zeros. And there's a jump of pi in between. So you could write those either way. And the other place that we're dividing by something is 1 plus cos theta. So 1 plus cos theta can't equal 0, which means that cos theta can't equal negative 1. When is cos theta equal to negative 1? Theta can't equal pi. That's the only place it's equal to negative 1, right? At pi. So then all the coterminal ones would be plus 2k pi, where k is an integer.
What is all that, like cos theta not equal to 0? Why did you do it way different than when you did sine theta equal to 0?
Why are these, the first ones, why are these two answers different than sine? If you go back in your notes to, I think it's in chapter 6.5 when we first looked at sine and cos, and we looked at the properties and wrote down the zeros of sine and the zeros of cos, that's when we first talked about how to write them down. If you think about your graph, so Carson, one way to figure out where the zeros are is think about your cos graph. It has zeros at pi over 2, 3 pi over 2. The next one's going to be 5 pi over 2. And then 7 pi over 2, and so on. And it also goes in the negative direction. Yeah, so there, the second one makes sense to you because it's plus pi in between each one. Okay, so that's why you have two choices. The first one's based on the fact that this makes every odd number. 2 times any number makes it even, plus 1 makes it odd. Yes, question? Yeah. This part here, the 1 plus secant theta, that will translate into 1 plus cos theta equals 0. They're going to be the same. So anytime you have a reciprocal function, if you show all your work with changing the reciprocal and proving it, where that 1 plus secant theta is equal to 0 will show up later as 1 plus cos theta. Yeah, so watch if I set this, say this can't equal 0, okay? So secant theta can't equal -1, and then the reciprocal cos theta can't equal 1 over -1. That's the same as here. Okay, questions for practice on this one are for 8II, 9II, and then II, or 11.